Hey guys, it's Eric here again. So by now, you should have set up your model in Padlet. As your project team was setting up your model, you were prompted to create conditional statements that predicted how your project team thought one factor might impact other factors within your model. Now that your model is set up, we can use those conditional statements to help us think logically about how these different factors might affect the sand volume on Crystal Cove's North Beach. Some of these factors have direct impacts on the sand volume on the North Beach. For example, the relationship between wave frequency here and sand volume here is a direct relationship with one set of conditional statements. There are no intermediary factors between them. That means that if I wanted to look at how wave frequency might impact the sand volume, I only need to take a look at this one set of conditional statements. But what if there are indirect relationships that affect the sand volume? How do we know how that indirect component or process will affect the sand volume? Well, let's take storm strength over here, for example. So, storm strength is one and two steps removed from sand volume. Or, in other words, there are two conditional statements between the factor of storm strength and sand volume. This is where our conditional statements come in handy. I can use these conditional statements to set up a proof, just like you might in geometry, to help us think through the logic and how storm strength might affect the sand volume on the North Beach. So I want to know what happens to the sand volume on the North Beach if there is an increase in the strength of storms over time. So what I will do is I will follow that same pathway from storm strength to wave frequency to sand volume to see how an increase in storm strength over time causes sand volume to change. So if I follow this first set of conditionals between storm strength and wave frequency, I can see that if storm strength increases, then wave frequency will increase. Next, I can go to my second set of conditional statements and look for if wave frequency increases. So number one here reads, if wave frequency increases, then the sand volume will decrease. So by following that logic, it brings me to be able to conclude the proof by saying that if storm strength increases, sand volume will decrease. One factor on your list may also have a relationship with more than one factor, and that is okay. For example, you may have noticed that when we were looking at storm strength, it also affects other factors on my model here. So you'll see that it has a relationship between wind strength as well as wave power. So if I wanted to follow the conditional statements in a different path, I could do so as well. So here I have storm strength with wave power. So let's go again with an increase in storm strength. So if storm strength increases, then wave power will increase. And over here, if wave power increases, then the sand volume will decrease. So that's about it. Go ahead and play with your model and see how changes to the system affect sand volume on the North Beach by following your conditional statements. Pick 4 or 5 factors in your model that are at least 2 steps removed from sand volume and practice creating proofs in your field notebook to predict how these different factors might impact the sand volume on the North Beach according to your model.